Hi, welcome. I am Arnab Chakraborty from Updegree. In this video, we are going to cover Introduction to Correlation and Regression. So at first we shall go for the definition of correlation and also regression. Correlation is a statistical method used to determine whether a relationship between variables exists. That indicates that, say we are having one patient. One patient is taking some medicine for a certain number of days and the blood pressure of the patient. So are they correlated? That means the number of days the patient is taking or consuming the medicine and the blood pressure of the patient. The number of hours per day one student is studying and the final exam marks. Are they correlated? Is there any relationship between them? So that's why correlation is a statistical method used to determine whether a relationship between variables exists. Next one is the regression. Regression is a statistical method used to describe the nature of the relationship between the variables, whether it is positive or negative, linear or non-linear, and so on. So positive relationship means when x is increasing, y is also increasing. When x is decreasing, y is also decreasing. What is x? X means independent variable. What is that? That is the number of hours per day one student is studying on the average. And what is y? That is a dependent variable. What is that? That is the final exam marks. So in between x and y, what is the type of the relationship, nature of the relationship, positive or negative, linear or non-linear, that will be decided in our regression. So regression is a statistical method used to describe the nature of the relationship between the variables, that is positive or negative, linear or non-linear. A simple relationship can be also positive or negative. What is a positive relationship? A positive relationship exists when both variables increase or decrease at the same time. For instance, a person's height and weight are related and the relationship is positive, since the taller a person is, generally the more the person weighs. So that's why you can find that when x is increasing, that is independent variable is increasing, let it be height here, and the dependent variable y is also increasing, let it be weight here. So now in this case we are finding that they are positive, they are having the positive relationship. Why you are using the term generally? Generally means there will be some exceptions also. In a negative relationship, as one variable increases, the other variable decreases, and vice versa. What does it mean? For example, if you measure the strength of a people over 60 years of age, you will find that as age increases, strength generally decreases, and that is known as the negative relationship. That means x is increasing, y is decreasing, and vice versa. Number of absent days in a class for a particular student and the marks obtained in the final exam. So I think they are having negative relationship. As the number of days absent will be increasing, the marks obtained in the final exam will be decreasing, and there we can observe negative relationship there. Now we are going for the scatter plot and correlation. What is a scatter plot? Scatter plot is a graph of ordered pair xy. So what is x? That is the independent variable. What is y? That is the dependent variable. So ordered pair xy of numbers consisting of the independent variable x and the dependent variable y. So here you can find that we are having 1, 2, 3, 4, 5, 6 companies are there, and there is the respective the investments in the car business, so in $10,000. So you see these are the investments this particular 6 different companies have made, and the revenue they have earned in $1 billion. So they are coming here. So now if I plot them, I can find that here along the x-axis we're plotting the respective investments, and along the y-axis we're plotting the respective revenues earned, and you can find that when x is increasing, y is also having a tendency to get increased. So here we are observing the positive relationship here. I think you are getting my point. When x is increasing, y is also increasing. Take any one of them, 29.0 and 3.9. So 29.0 will be coming around here, and 3.9 is just below our 4 here. So this point is actually considering this one. So B point is there. So accordingly, if we plot x and y here, we are finding that x is increasing, then y is having a certain tendency to get increased. So here we are observing positive relationship. In case of negative relationship, we have taken one example, that is a student. How many students we have considered here? 7 students. And number of absences, so x is the independent variable, and the dependent variable is the final exam grade in percentage. So here you can find that if the number of absent days is increasing, if the number of days is increasing, then the respective final grade marks percentage is also decreasing. So X is increasing, Y is decreasing, or X is decreasing, Y is increasing. So here we are observing negative relationship. A correlation coefficient computed from the sample data measures the strength and direction of the linear relationship between two variables. The symbol of the sample correlation coefficient is small r. The symbol for the population correlation coefficient is rho, that is a Greek letter rho. So for the population, the correlation coefficient will be denoted by rho, and for the sample, that means the subset of the population, sometimes the population size is too big, not reachable to each and every sample there. So in that case, each and every member there. So in that case, we can take the subset of the population for the observation, also known as sample. So whenever we are calculating correlation coefficient on sample, it will be denoted by small r. So whenever there is no relationship, the value of r or rho will be 0. But whenever it will be having the strong positive relationship, it will be having the value of +1. Otherwise, it will be having the value of -1. So strong negative linear relationship, the correlation coefficient value will be -1. For strong positive linear relationship, the coefficient value will be +1. So within this range, you can consider that yes, we are having a very good positive relationship, and within this particular range, we can find if the correlation coefficient is lying in this range, then we can expect that it is showing the strong negative relationship here. So in this way, we are getting this idea. So R is equal to, you know that R is nothing but the correlation coefficient calculated on the sample. So if the R is 0.5, the scatter plot will be something like this. X-axis is containing the independent variable and Y-axis is containing the dependent variable value. So here the value of R will be 0.5, and here you see the points are scattered to some extent, but that is a certain tendency that if X increases, Y also increases. And it is 0.9, so it is almost tending towards a streamline. And whenever the correlation coefficient is 1, that is R is equal to 1, so in that case, all these points will be found on the straight line. And now you can find here if it is -0.5, so here the scatter plot will be something like this. When X increases, Y decreases, and whenever it will be -0.9, so it will be having a tendency like this, the pattern will be like this, and in case of -1, it will be found in a straight line, and you can find that the gradient here and the gradient here are totally different. So in this way, we are getting this idea, that is that how along with the correlation coefficient, how the scatter plot will vary. Now we are going to discuss the regression, that is a line of best fit. The reason to need a line of best fit is that the values of Y will be predicted on the values of X, and hence the closer the points are to the line, the better the fit and the prediction will be. So here you can find that this is the respective regression line they have considered, and these are the different points are there. Some points are falling on the line, and most of the points are falling either on the upper half or in the lower part of the regression line. But always I should draw this regression line in such a way that the distance between these points, that is the sum of the square of the distances, should be minimum. The sum of the square of the distances from the actual point on this particular line, the distance will be calculated using the perpendicular distance, and in this case the sum of the square of these distances should be minimum, and that line for which the sum of the squares of the distances will be minimum will be the regression line. So what will happen, say for a certain X, I don't have the respective Y there, so here I can go for this line, and if you put the value of X in this equation of this line, I'll be getting a certain value of Y, and that indicates that for this X, what will be the predicted value for Y. So in this way, you can find that how this regression line will help us for the predictions. Now, regression line equation. A line as represented in algebra and in statistics is something like this. So here you can find that the equation will be Y is equal to mx plus c. What is m? That is slope or gradient. What is x? That is the value along the x-axis, that is the independent variable value. And what is c? That is our y-intercept. So here this intercept is this one. And what is m? How to calculate m? So m is nothing but delta y by delta x. So if you consider 2 points on this line, then this point is having say value x1 y1, this point is having the coordinates say x2 y2. So x2 minus x1 is delta x, and y2 minus y1 will be delta y. So delta y by delta x, let it be 2 by 4 is equal to 0.5, and in that case the m will be having the value 0.5, and let us suppose this intercept is having the value of 5, so y is equal to 0.5 x plus 5. So in this way, in algebra we define one straight line. In case of statistical notation for a regression line, you can find here we are having this y dash is equal to a plus bx. What is a y dash? That is a predictive y. That is a predictive y, not y actual. That is a predictive y. So y dash. Otherwise, we can also represent it as a y kappa or y hat. So is equal to a plus bx. So what is a? That is about y dash or y prime intercept, and what is b? That is known as a slope. So if delta x is equal to 4 and delta y dash is equal to 2, so b, that is the slope, can be calculated as delta y dash by delta x. So that is about 0.5, and if the intercept is about 5, so 5 plus 0.5 x will be the equation for this. Y dash is equal to 5 plus 0.5 x will be the equation for this regression line. So in our statistical notation for a regression line, the expression will be y dash is equal to a plus bx. This is the equation for the regression line in statistical notation, where a is the intercept and b is the respective slope. So in our video, we have discussed what is the correlation, what is the regression, and what is the measure of the correlation coefficient and all. I think we are getting this idea. In the next sessions, we'll be discussing more on this topic. Thanks for watching.